we have already covered this whole question. So, right, everything we have just done. But this last point, right, I already mentioned in the beginning, but I am mentioning again that you see, lots of people gave some wrong answers. As I said, that say, change the material and take a lower flow stress. So you see, that is a design question that you cannot do, right? Change the width, you cannot do that, and so on, right? So look at the formula to help you out. Of course, some of you did not look at the formula at all. This is already a bad thing, that you see the formula sheet is there. You already know about the rolling, so you can think from your mind, how can I reduce the roll force? That is good. But the formula is there, and just see what are the factors. So one thing is, those guys who do not look at the formula when the formula sheet is there, they are not being very intelligent. And then the others who look at the formula and blindly say, reduce this, reduce this, reduce this, reduce this, then this is not very nice, right? So this is about it, about this question. We will now move into the other questions. Let me just leave you with a small, more enjoyable moment. A man was in his office, and he got too tired and so on with meetings and work and so on. So he said that for a couple of minutes, I will relax. So he made a call and said, hello, darling, how are you? And then he got the answer, what? You are in such a good mood, you are calling me darling? And what happened to the fight in the morning when you left for office? He suddenly closed the phone and said, my goodness, I called my wife. Joke is over. So that is it. Let us go to question 1b. What are the advantages and disadvantages of using a lubricant in forging operations? Right, so again, if you just think, you can give the answers, but let us see. Advantages first. Reduction in force and energy required, right? If you use a lubricant, then it will be easy to force it in forging, so you will reduce the force and the energy and the power required. One major thing. Reduced localization of a strain resulting in improved forgeability. So this is easy, right? First of all, reduction in force. Second, it will make easy to forge, right? So this is obvious. Lubricant acts as a thermal barrier so that the part can remain hotter longer and thus have more ductility. So if you are doing hot forging, then the lubricant will trap the heat. It will not make it so quick for the heat to go away, and this will be easier for the process if it is hot lubrication, hot forging. Lubricant can protect the workpiece from the environment, especially in hot forging. If it is hot forging, then air and oxygen and so on can start reacting. But if the lubricant is there on top of the metal, then it will stop the interaction or the chemical reaction. So this will be good. Lubricant can act as a parting agent, right? After you have done the forging, you have forced the punch or the die into the material, so sometimes they can stick together and it is difficult to remove them, right? So it can act as a parting agent. It will be easy to make them apart, right? Make them away from each other. So these are very good advantages of the process, right? These are very good advantages of the process. Let us go and see some disadvantages of using a lubricant. Lubricant adds cost to the operation, of course, right? Lubricant, and especially a lubricant which is of a good quality for forging either cold or hot, will be some cost. A thick film of the lubricant can result in a defect called orange peel. So I will not explain this defect because you have studied what are the defects during forging. One of the defects is orange peel. It is a defect that happens on the surface of the forged component. So a thick lubricant can do this. Lubricants may be entrapped in the die cavities, thus part dimensions may not be acceptable. So if some of the lubricant after forging is still inside, then this will change the dimensions and so on, which happens rarely, but it can happen. Lubricant must subsequently be removed from the part surface, which is an additional and difficult operation. You initially applied the lubricant, it made things very easy, but once the forging is done, this lubricant is still on the surface and you have to remove it very carefully, because if the lubricant is still there when you are using the part, then it will be bad. So this is a costly and time consuming process. Disposal of the lubricant can present environmental shortcomings. So this is always that lubricant is something which you need to dispose, right? Just like your engine oil and so on, you have to throw it away, and you can throw it away at a certain cost only. So this will be again one of the disadvantages. Let's move to the other question, 1C, which I'm calling it. Besides flat rolling and shape rolling, name at least 3 bulk forming processes that use rolls to produce deformation. So it is a very simple one. I mean, you know, rolling, flat rolling, rolling without any shape, shape rolling, rolling with some dies and shapes. And so just name some of the others which belong to the rolling category. So some other processes and rolls are ring rolling, okay, thread rolling, gear rolling, roll piercing, roll forging, right? So you know these, and hopefully most of you answered them correctly. Some may have forgotten a little, but this is just that that general reading part, where after explaining the full details and so on, we give you the major names and so on of some major technologies in each type of manufacturing process. Question 1D now. One way to classify forging operations is by the degree to which the work is constrained in the die. By this classification, name the 3 basic types. So hopefully you understood. Constraining means that how much are we forcing the work to be inside the die, and how are we doing it, right? The way we force or constrain the material inside the die. By this we want to do the classification, not horizontal, vertical, this and that. So let us see these. There are 3 basic types. Open die forging, you don't constrain it, right? You just press it and it keeps on decreasing in height and increasing in the area. So you are not constraining it, right? So zero constraining, open die forging. Impression die forging, you have a die with a certain shape and you force the material into that. So this is impression die forging. And flashless forging, if you remember, right? In impression die forging, flashless is also impression. You make an impression, you make a shape, but in number 2 you allow excess material to flow outside. But in number 3, all the material of the billet goes exactly into the die, so you are not allowing any flash to happen, right? So this is flashless. So by this classification of how do we constrain the material or not, these are the 3 methods. Why is flash desirable in impression die forging, right? In this one is flashless, one is normal impression die. Why is flash desirable? So first of all, is it desirable? Do we want it? If we have flashless, then there will be no wastage of material. All the material of the die will go inside. But in normal impression die forging, we will force the material by pressing it into the die. Excess material will be forced outside. So what is the advantage of this? Because its presence constrains or forces the metal in the die to fill the details of the die cavity. Right? We are trying to fill it. Now some material is trying to flow out, but this extra material outside is not allowing the rest of the material which is going inside the die to, right? So compare it to casting. You pour the metal inside the mold is completely full, but maybe afterwards it will shrink. So how do we make sure that after cooling it will still be the full size? We make a riser after the mold cavity. So material initially fills completely the die cavity and then rises into the riser. So it is some extra material is now there. So even if it cools and shrinks, there is extra material there and it is completely filled inside the mold cavity of the casting. So here it is something like that, that when this flash is there, first the material is going inside, it is completely filling all the nooks and crannies and every portion of the die, and afterwards it is coming out. So it is constraining, it is forcing the material to go and fill all the portions of the die and not leave anything behind unfilled. So this is this part of the question. The next question, 1E. Write correct names below each of the rolling defects shown below, and we are showing these 4 defects. So this is just that, right? I mentioned to you that knowing the defects in every process is very critical, because if you don't know what type of defects will be formed and what are the reasons, then you cannot run the operation well, right? Whenever you want to remove the defects and want to improve the productivity and efficiency and reduce the amount of excess work in correcting the defects and so on, then you should know it. So just the names. So this one is called wavy edges. This is called zipper cracks. This is called edge cracks, and this is called alligatoring. You know, alligator, crocodile. So because the mouth opens up like an alligator, so it is called alligatoring. And here I did not want to discuss any details and so on, just the names. Just the names. Now to the numerical question part, question 2. A metal component is in the form of a solid cylinder of diameter 1524 millimeter. Using the operation of upsetting, its height is reduced from 1016 millimeter to 508 millimeter. What will be the force at the end of the upsetting operation? Material constants for plastic deformation of the cylinder are 1015 megapascal and 0.17. Coefficient of friction between the punch and the cylinder is 0.2. So this is now once again the numerical type. So of course you can immediately see the solution, but it will be better for you to pause my lecture here and resolve it once again as a practice for the final. And once you are sure of your answer, then look ahead and so on, right? That is what my suggestion always is. So you pause here, and after the pause you start listening. So if you are listening now, then you have already solved it. As I always tell you, that you first should write the data. So there is a cylinder, the initial dia is 1524. Upsetting is being done, which means it is a forging operation. Forging is also called upsetting. Initial height is 1016 millimeter. Final height is 508 millimeter. K of the material, right? Constants of the material is 1015 megapascal. N is 0.17. The coefficient of friction is 0.2. And they want to find force at the end of the operation. Force at the end of the operation. This is the question.